Hi everyone. In this video, I'm going to be talking about reducing agents and reduction reactions. So reduction refers to a decrease in your oxidation state, and this typically occurs when we lose bonds to oxygen or when we gain bonds to carbon. So essentially, there are many good reducing agents that we'll be going into, but first I just want to give you an example of what a reduction looks like. So let's start with our good old aldehyde. Let's say we want to perform a reduction on this aldehyde and we want to take it all the way to an alcohol. Well, if we did that, then we would expect to look something like this. Now we'll notice here that there is a reduction in the number of bonds that are bonded to oxygen, and we now have an additional bond to hydrogen. So this is known as a reduction reaction, and this essentially means that the oxidation state of the atom that we're focused on has decreased. So essentially, a bond between a carbon atom and an electronegative atom is replaced by a bond to an atom that's less electronegative than the initial atom. So in that case, this bond, which is bound to O, is now bound to H, which is less electronegative than oxygen. All right, so now we can go into the reagents that are responsible for carrying out reduction reactions and commonly found reducing agents that we see in organic chemistry. So there are a number of commonly used reducing agents in organic chemistry reactions, and for the most part, these are metal hydrides. So something like LiAlH4, it's a metal hydride. NaBH4 is another metal hydride, Na being the metal. Also CaH2, and you might even sometimes see NaH. So these are all commonly used as reducing agents, and the two that you're going to come across the most are LiAlH4 and NaBH4. So those are the ones that you'll typically see in your courses and your classes. All right, so two really important facts that I would take away from classifying reducing agents is that reducing agents are often metal hydrides, like we just saw, and that reduction reactions, they typically increase the number of bonds to hydrogen, typically bonds to more electronegative atoms are replaced by bonds. All right, so now we're going to go through the reagents that take us from a reactant to a specific product, and this is basically identifying reagents that would perform these specific reactions. So start off with the first one in red. So here we've got an aldehyde, and it's being reduced down to an alcohol. So a good reagent for this reaction, we could use either LiAlH4, or we could also use NaBH4. So these are both good options to take us from an aldehyde to an alcohol. The next one, orange, is taking us from a ketone to an alcohol. This time, this is a more substituted alcohol because of our two R groups on the ketone. So in this case, we could treat this just like we did the above reaction, and this reaction can proceed using either LiAlH4 or NaBH4. Alrighty, so the one in green, now we've got a carboxylic acid going on, and we're taking this carboxylic acid down to an alcohol. So what we're seeing here is we're essentially removing 2 bonds from oxygen. This really requires a strong reducing agent, and usually this can be done by LiAlH4. However, it's necessary to add ether along with LiAlH4, and then followed up by H2O, water. And that will give us the product from a carboxylic acid to primary alcohol. So now our last one in blue shows an ester. So this is an ester molecule, and this is really interesting because it has 2 different R groups, but we want to take it to a primary alcohol, actually 2 primary alcohols we've got here. And we're able to do this because by using the reaction, or by using the reagents LiAlH4 and ether, followed up by H2O, both of these reagents will give us 2 primary alcohols. Essentially, the bond here is going to be removed, and we will be protonating this O and then protonating this O. Thanks for watching, guys.